Hello, I'm Greg. Welcome to my channel, Midnight Oil Software, and episode 20 of my series on how to make a 3D space shooter game in Unity. One of my viewers requested a video on how to add a target leading indicator so you can see where you need to aim to lead your target with your blaster shots. And so that's what I'm going to do in this video. So if you find that interesting, then grab your favorite beverage, pull up a chair, and follow along as I teach you how to make a 3D space shooter game in Unity. So basically, this video was requested by one of my viewers, a fellow named Sandeep. He wrote to me on my Discord server, Greg, I am working on leading targeting system. Can you help me with making a UI leading targeting system that tracks where an enemy is going to be when you shoot the projectiles? And I threw together some code that I thought would kind of get him started, and he did say that that worked. But I thought that this topic was interesting enough that I could actually do a video on it and go into a little bit greater detail than what I gave him and actually come up with a bit more sophisticated targeting system using quadratic equations to actually predict the position the ship would be based on the position and speed and facing of the target, the location of the launching ship, and the speed of the projectiles. So the very first thing that I want to do is I want to come into Unity, and just for the sake of making it easy for me to test this, I want to change my ship controller movement and weapon controls away from gamepad back to the desktop controls. I had added the gamepad support in the previous video, but I find using the keyboard and mouse to be easier. So I definitely wanted to go ahead and change that back. The other thing I wanted to do is I want to actually create a UI element that we can use for our leading indicator. Now we've already got, under our prefabs and UI, we've got this target box. And that's got the script that I'm actually going to put the implementation of this leading indicator in the target indicator script that's already there, because there's already some functionality in there that we want, like is the target visible, some things that we're going to leverage as part of this. And I could make this a totally separate component and totally separate script, but I'm just going to go ahead and throw it in there. But first we need a UI element. So what I'm going to do is I'm going to come in here to the managers, and there is a UI manager which has a canvas. And we're going to make this new guy be a child of that canvas. So I'm going to right click here and I'm going to say UI image. So we're going to create a new image there, and I'm going to call this target lead indicator. And then for our image, I want to pick something that I think would make a nice, not too big, something kind of like this or this is what I'm leaning towards. I think I'm going to go with this guy here. There's other possibilities. Actually, maybe this guy, because I don't know if I want him to be quite that big. We'll try this crosshair right here. And then I want to make it red. So the target box that we use to bracket the enemy ship, it's definitely going to be red, and so I want this to be red as well, because this is only going to appear on enemy ships. The other thing that I want to do is I want to go into our prefabs, UI, and I just want to drag this guy into there and create a prefab for it, and then delete it from right here. Now we're going to want to go into our script for our target box, and we're going to modify some stuff in this script so that we can calculate where we want to display that lead target indicator and actually display it. So first of all, we need a prefab for our indicator. So I'm going to create a serialized field here, and that will just be a game object. And I'm going to call that target lead indicator prefab. GitHub Copilot is always so helpful. I'm also going to add a float parameter here, and I'm going to call this projectile speed. And I'm going to use this to calculate the expected or projected point at which we're going to intercept the target. And this is hard-coded. I'm doing some experimentation with some debug logging in my projectile to see how fast it goes, because I'm launching the projectile using physics by just applying torque, or launch force rather, applying force. And so the speed is actually a factor of force times mass, which equals acceleration. There's a formula that will take that acceleration and the mass and everything else and calculate the speed. But I'm just going to go ahead and hard code this here for simplicity. I need a few more variables here. We're going to need a rigid body for our target. And we're going to need to keep track of the player, because we're going to use the player's position as part of the calculation, because we're going to be launching the projectile from the player's position. And we're also going to want our target lead indicator that we're going to instantiate and move around and frequently update. So I'm going to move the init function that we're using to initialize our variables up here to the top. And in here, we're going to get a reference to our player. And I'm not super happy about the way I'm doing this. Right now, the player doesn't take any damage and can't be destroyed. So I know I can just grab the player here and always have an instance to him. If we take this series farther into the future and we allow the player ship to be destroyed, we're going to have to be spawning new players. And we're going to want to use some kind of a player ship manager or something to get this instance. But for now, we're just going to go find it by tag. The other thing I want to do is we want to instantiate our target lead indicator that we're actually going to be using to display on the screen. Now, because we now are instantiating this guy here, I want to add an onDestroy method. And in here, I basically want to set that target lead indicator to inactive, and then call GameObjectDestroy on that target lead indicator. Okay, if we scroll down into late update, this is where, if our target's visible, we display the target rectangle over the target. What we're going to do is here, we're going to add another call, and we're going to call that update target leading indicator. And I'll go ahead and create that function. And if we're not doing that, then we want to basically turn off the indicator. Except we want this to be false. All right, so if we are updating it, we're just going to return out of here. If we fall through to here, we know we're not displaying it, and so we are going to set that to inactive. Now, update leading indicator, target leading indicator, is going to calculate the predicted position. So I'm going to say predicted position equals calculate predicted position. And then I'm going to call display target lead indicator at that predicted position. So obviously neither of these functions exist, so we're going to go ahead and create them. And this is going to actually return a vector 3. Okay, so calculate predicted position. I'm going to copy and paste this code into here and then walk through it with you. You don't need to watch me type all this. All right. So basically, we want to initialize our intercept position to be the target's current position, because it's possible we're not going to be able to get a solution to intercept the target. We're going to be doing some quadratic equations, and I will be honest and say that I actually used ChatGPT to help me come up with the math for this function. We're going to basically, this isn't really relative velocity because I'm just taking the target's velocity, but I'm grabbing the target's velocity because the equation wants relative velocity, and our relative position is going to be the target's position minus the player's position. And we're going to calculate three coefficients that we're going to use for the quadratic equation using dot products. The first one is going to take the relative velocity, and then it's going to subtract the projectile speed squared. Okay. The second coefficient is going to take 2 times the dot product of the relative velocity and relative position. And then the third one is just going to take the dot product of the relative position and relative position. So if you want an explanation of how that works and all that's doing, that's a little bit beyond me. Trust me, this code will work. But now we need to see if we come up with a good solution. So I'm going to take the absolute value of the A coefficient, and if it's less than 0, that means it's impossible to solve this intercept. So I'm just going to return the target's current position. And then we're going to calculate a discriminant using the B coefficients, the A and C coefficients with this formula here, B times B minus 4 times A times C. And if that value is less than 0, then again, there's no real solution, so I'm just going to return the target's current position. Now we want to look at 2 possible times to impact. So we're going to take the square root of that discriminant, and then we're going to calculate 2 times. One's going to be negative B minus the square root divided by 2 times A. The other one's going to be time 2, which is going to be negative B plus the square root of the discriminant divided by 2 times A. And we're going to take the greater of those, and if that is less than 0, we're very near 0, then again, there's no possible solution. We're just going to return the target's current position. Otherwise, we're going to take the target's current velocity times the impact time, and we're going to add that to their current position. And that is going to be our intercept position. All right. Now, we need to display the target lead indicator. So again, I'm going to paste this code in here. So this is going to be a vector 3 called target position. And that should fix that compilation error. So we're going to calculate the viewport position of our target position. So this is the actual 3D position in world space. We're going to convert that to a viewport position. And then we are going to turn on or enable our indicator if the target is visible. And if we did not set that active, then we're just going to return out of here because we don't need to move it because it's not visible. If it is visible, then we want to take that viewport position and get the screen point for the main camera. And we set the Z-axis to 0 because we want to make sure that it's in front of the camera. And then we are just going to assign that to our target lead indicator's transform position. That should be all we need to do to actually get that thing to show up. So I'm going to jump back out here into Unity and let things recompile. Alrighty. So we come over here to our targetable prefab. And we need to drag in our target lead indicator prefab. And let's see what happens if we play. And in a few seconds, we'll see a target spawn in. And there's one behind us. And he's shooting at us. Okay, and I do not see our target reticle. So I obviously didn't set something up correctly. Let's go see what I could have missed. Oh, I have an error in the console. That's always a hint. Target rigid body. Did I not get my rigid body? I did not. Okay, so up in init, let's go see what we did here and what I missed. I got the player. I instantiated that, but I never got the target rigid body. So what I will do is say target rigid body. Oops. Target rigid body equals target.get component rigid body. All right, let's jump back out and see if that doesn't fix it. And there he is. And there's the target reticle. Boom, he just hit me with a missile. Okay, and you can see that the reticle moves just a little bit in front of the ship. So like I said, as fast as my projectiles are flying, we really don't need that much lead. Now, if I was to go back into our target box here, and I was to change my projectile speed that I'm using for my calculation to be something like 200. Another thing I could do is I could make our enemy ship much less maneuverable so he can't turn as fast. That would make a big difference. But I'm going to leave this right here. And this is going to make my estimate very inaccurate because it's going to, you know, as fast as I'm launching my projectiles, they're going to get there a lot faster than this thinks they will. But at least it will show you how it will affect the calculation of where it puts that target reticle. Yeah, see how much farther out in front it is? And so you can tweak those values by making it a serialized field. We can tweak it. And so one thing I can do is I can go into my prefab for my projectile. Go into the script. And in update here, I can just do a Debug.Log. And I can say name velocity, and it will display the velocity by taking the velocity's magnitude off of the rigid body. Come back out here. And so depending on how much launch force you apply to your projectile, it's going to, you know, max out at a certain velocity. I don't even need to wait for a target. I just hit fire a few times. So if you look in my console log, you can see that my velocity was mostly around 800. You know, when it was first launched, it was 0, and it quickly got up to around 800 and remained pretty constant at 800. So if I wanted to very accurately calculate the position of that target indicator, I would plug 800 into that speed. And like I said, you can play around with your projectile's launch force. You can play around with the maneuverability of the enemy ship. And all those values would need to be taken into account if you want that to be accurate. Well, I hope you found that useful, and if you did, do me a favor and click that like and subscribe button. It really does help to grow my channel. And if you have any questions or comments about anything I've shared in this video, you can either drop a comment on this video, or better yet, go join my Discord server. I'll put a link in the description. And all the code for this lesson will be up on my GitHub, GitLab page. Actually, I think it is GitHub. But I'll put a link in the description for that as well. Thanks so much for watching, and good luck on your game development journey.